Let us look at what? Derivative of tan x from first principle method. So if you still remember, we have explained the derivative of sine by using first principle, and then we have explained the derivative of what? Of cos by using first principle. So the last one, which is the next one, is derivative of what? Of tan x by using what? First principle. Good. We will apply the same procedure. The one we did for what? For sine and cos. We apply it here too. So by doing that, we said if y is equal to what? Tan x. Let me call it equation 1. So if y equal to the what? Tan x, the common principle of the first principle, you will add a small increment to y and add a small increment to what? To x. By doing that, what are we going to have? We will have y plus increment, which is changing y, equal to the what? Tan, equal to the what? X plus changing what? X. From this now, we have add increment to the x and y. Let's make this change in y as subject of the formula. By doing that, I'm going to have change in y should be equal to the tan of x plus change in x minus y. But if you look at the first equation here, it's already divine y for us. And y is what? Tan what? Tan x. So from there, substitute for this y by this, we have change in y equal to the what? Tan of x plus change in y minus tan x. So this is tan x. From this expression now, I want to remove tan totally from this equation. That now reminds me from the trig identity. I told you before that if you don't want to have problem with differentiation and integration of calculus, you must go and learn trig very well. So by applying the trig, now I can now say recall from trig that tan x is equal to what? Sin x over what? Cos x. So that is everything we have here now. I will change it to the sine and cos. We have y should be equal to what? This term will be equal to sine what? X plus change in x over cos x plus change in y. This tan x plus change in tan x plus change in x is this what? Sine over cos for this. This term understand alone is here. You now have what? Sine x over what? Cos x. Are we? Good. The next thing that we now do now is what? Apply a normal fraction. So by applying normal fraction, the change in y will now give us what? Sine x plus change in x. This will go here, cos x. This one will be minus sine s. This one will come here into what? It will come here to become what? Sine x plus change in x. Good. Everything over the 2 here, we have cos x plus change in x cos x. This is what? The base. This cos come here. This one will come here. That's what we apply here. From that, we can proceed to, if you look at this expression, there is a particular formula under compound angle which helps us to what? You can say what? We call again that sine angle of A minus B is equal to what we call what? Sine A cos B minus cos A sine B. If we agree this, you can now say let A equal to what? S plus sine x and B equal to the what? X. What I'm trying to say here is what? This S plus change in x is A. This what? X is what? Is B. If that be the case now, you can simplify this equation to be in this form. Why? Good. You know that what? All this expression we have here, everything we have here is equal to the what? To this. We now have sine what? A minus B. What is A? X plus change in x. Yes, that is A. Good. Minus B. What is B? X. Everything over what? Cos what? X plus change in x. Then cos x. Everything we have up here is equal to this, because everything we have here is equal to this. So all this now, they are this identity. When A is what and B is what. So that's I simplify this to what. And the next thing we do is this, we cancel this out. We are left with what? Y should be sine change in what? X over what? We have cos x plus change in x cos x. The next thing that we do is what? I will divide both sides by changing x. By doing that, so this expression will metamorphosize to what? Sine what? Change in x over this will divide change in what? X. We have what? Cos x plus change in x cos x dot change in what? The change in x that we use to divide both sides. So by doing that, we are solving further to have dy dx should be, this is sine, I want to take this sine out. So to have 1 over what? Cos of what? X plus change in x Then cos x, everything multiplied by what? Let me take this cos sign out. Sine changing x over what? Changing x. If I take this sine changing x out with this one, if you have this. And there is a particular rules which always tell us that what? Whenever we have sine, let me say, sine angle of P over what? P. Or sine angle of changing s, of a changing s, is always equal to what? 1. By applying this, our equation will reduce to what? Changing yx, 1 over what? Cos of x plus changing x, cos x, everything into what? 1. What we have here. So by doing that, we can now conclude that what? Dy, the s, limits that changing s tends to the 0. So the y dx will be 1 over cos of x plus 0 cos x. This is 10 to the 0. You will now have what? Dy, the x will be 1 over what? Cos x dot cos what? X. What is cos x times cos x? Will give us what? 1 over what? Cos square x. So from the trig identity, again, recall the trig tell us that whenever we have 1 over what? Over cos, 1 over cos x, it tells us that what? It's always be what? Sec x. Since 1 over cos is sec x, therefore, we have dy dx should be equal to the what? Sec square x. So this is the derivative of what? Of tan theta. So derivative of tan theta by using first principle is what? Is sec square what? X. So the next thing is what? Let us look at what? The general derivative of trigonometric function. So after that, we move to the what? Exponential function. After exponential, logarithm. Logarithm, look at what? Parametric, then inverse function.